so we're going to start with a question that we're going to have a problem answering, but then I got a solution for that, so relax. Let's say, for example, I have the function f of x equals 2 to the x, and I would like you to find the inverse. Okay, so let's think about the steps here. Step number 1 is to replace f of x with y. Okay, it's not too bad, so that's just y equals 2 to the x. Okay, I'm on board, we're there. Then our second step is to swap x and y places for inverses, so we get x equals 2 to the y. And then our third step is to solve for y. And at that point, we sort of hit a snag, because y is in the exponent. So how do we get access to the exponent? How do we, how's that work exactly? So awesome. I asked a question that we don't know how to answer quite yet. Okay, but we have a process to figure that out. Okay, so what happened here? It says we can't find the inverse of an exponential function because we've not yet learned, I think it's not yet, we're about to, learned how to solve for y in the exponent. So we need a new notation for the inverse of an exponential. So I want to try to convince you, for starters, that prior to this moment, we don't have a way to do this. So we've got to have a new tool that allows us to answer this specific question. Okay, and honestly, this isn't a new idea for us. We were actually familiar with coming up with a new tool to undo an operation. So, for example, subtraction is the opposite of addition. What's the opposite of multiplication? Division. And what about square? What's the opposite of squaring? Well, that would be a square root. Would be considered an opposite. And so the opposite of an exponential function, or inverse, in the thing that undoes it, we call that a logarithm. Okay, L-O-G-A-R-I-T-H-M. All right, so what exactly is a logarithm? Okay, so this is what we're going to say. We're going to say that b to the y power is equivalent to x if and only if log base b of x equals y. Okay, and again, that's, I'm going to kind of write that out. That's log base b of x equals y. And again, this is a new notation for us, so we have to have a way to say that out loud. Okay, and a couple of just ideas that I want to connect with you. Notice x and y are connected here, x and y are connected there. They sort of switched places on us. Okay, so the base stays the same for both notations, but we switch the x and y. And of course, why would we switch x and y? Because these are inverses. We need a new notation that allows us to take the inverse of an exponential, and the inverse being a logarithm. Okay. And now in dealing with logarithms, we actually have a couple of common logs that are just come up enough times that we actually bothered to give it a special notation. And this is something that you've seen on your calculator many, many times, and unless you've had experience with this type of topic before, you've probably never known what that button does. So log base 10 we refer to as the common log, and we just call it log x. So if you don't see a number there listed as the base, we assume it to be log base 10. The natural log related to the natural number we refer to as the ln. Okay, so if you ever see the log or the ln, we're assuming that log is going to be base 10 and the ln is base e. Okay, so a couple of very common forms that we'll get exposure to. So log base b of x in log form. If we convert that to its equivalent exponential form, it's b raised to the y power equals x. Log of x, again, there's an understood base 10 there. So that would translate in exponential form as 10 to the y equals x. And ln, and again, there's an understood e that we don't see. And so that would translate to e to the y equals x. Okay, one other quick comment about this sort of thing, and I want to kind of go back to elementary school days. Remember those days when you had to practice writing, and you had that lovely little lined paper that you kind of practiced with? A lot of students rush with exponents, and especially with the subscript and the superscript, and sort of miss the details of what the number actually physically means. So you want to be very careful in how you write this. So let me kind of show you what I mean. So log, and then our base, sort of a lower, sort of below the line, x equals y. Okay, it's going to be very visible that that's a base of the log. Exponent, by the way. So here we want b to the y equals x. So it's got to be very clear what these bases and what these exponents are. You want to avoid sort of log bx equal, you want to kind of watch this, that you're not writing so fast that it's really hard to tell whether it's a coefficient or whether it's a base. I know it sounds really silly, but if you take your time with this, you'll make a lot less silly mistakes because you understand what the notation is trying to tell you. We're going to take a few minutes and just practice converting from one form to the other. So I'm going to kind of put the conversion formula kind of up to the side here. So that'd be log base b of x equals y translates to b to the y equals x. Okay, just kind of remind us of how that goes. Alright, so 2 equals log base 5 of x. Let's convert that into its exponent form. So one easy way to think about that, I'm going to take that base and I'm going to bring that underneath the 2. So that translates to 5 squared equals x. And that's like for right now, for this activity, that's actually good enough. I know 5 squared is 25, but the point being we're just converting from one form to the other. Okay, what about log base 4 of 64 equals 3? Okay, so we're going to take this, slide it underneath. So 4 cubed equals 64. Ln of 7 equals y. We don't see a base, but it's understood that it's base e. So we're going to slide that underneath. So e to the y equals 7. Okay, let's go the other direction. This time I've got the base, so the base is going to be the same. So if it's 12 squared, what's the base of the log? It's log base 12. And then I need to switch the x and the y places. So log base 12 of x equals 2. Okay, this next one, log base. What's the base of the exponent? That's base b. We're going to switch x and y places. So log base b of 8 equals 3. Then, same thing here. I need a base. So log base. What's the base? E. Then we're going to switch 9 and y places. So log base e of 9 equals y. And we can go one more step because that's one of our special log bases. So we actually can rewrite that as ln of 9 equals y. So now that we understand how to convert from log form to exponent form, we're going to practice simplifying without a calculator. So again, using our understanding of exponents to simplify some log expressions. Okay, so what we're going to do, so it kind of makes sense in our heads, we're going to set log equal to x, and then we're going to switch the log equation to exponential form. So just practice that process that we just looked at. Then we're going to solve for x and then remove x from our final answer. Okay, so let me kind of show you what I'm talking about here. I would like to simplify log base 2 of 16. So I'm going to set that equal to x for a moment, and then I'm going to rewrite this in terms of its exponent form. So remember, we take that base. So what's the base of the exponent? It's 2. And then I want to switch the x and y places. So 2 raised to the x power equals 16. Okay, now here's where our sort of thinking skills are going to kick in. Is there a power of 2 that happens to be equal to 16? Well, if you can't think of it, then we're just going to run down the list. So 2 to the first is 2, 2 squared is 4, 2 cubed is 8, 2 to the fourth is 16. Okay, so that's 2 to the fourth. So logically then we just get x equals 4. So log base 2 of 16 equals 4. Okay, let's run next door. Log base 3 of 9, what does that mean, simplify to? Okay, so we're going to set that equal to x. The base of the log is 3, so what's the base of the exponent? That's 3. Switch those two guy places. So log 3 to the x equals 9. And so hopefully we got this one. What power of 3 is 9? 3 squared. So that means x has to be 2. So log base 3 of 9 is 2. Yay. Alright, log base 25 of 5. Okay. So set that equal to x. What's the base of the log? 25. So what's the base of the exponent? 25 as well. Swap those guys places. So 25 to the x equals 5. Now in this case, we kind of need to think out loud to ourselves. Okay, so what is the relationship there? 25 is really 5 squared, isn't it? That's 5 to the first. Okay, and so we have this rule that says if I take an exponent to an exponent, that means multiplying. Okay, so that means 2x has to equal 1, so what is x? 1/2. Okay, so log base 25 of 5 equals 1/2. Okay, let's keep going here. Alright, so log base 7 of 7 equals x. Okay, so what is the exponent? What is the base of the exponent? That's 7. Raised to the x power equals what? 7. Oh, okay, that's interesting. 7 by itself is just to the first, so that's 1. So log base 7 of 7 is 1. It's an interesting observation. We'll have to come back and formally come up with a property for that one. Let's see, log base 7 is 7 squared. Okay, so that equals x. Alright, so what's the base of the exponent? 7 raised to the x power equals 7 squared. Ooh, what's x? 2. Alright, so log base 7 of 7 squared simplifies down to 2. And I'm thinking there's another general property we could probably write from that. Log base 5 of 1 equals x. Okay. Alright, what's the base of the exponent then? 5 raised to the x power equals 1. Alright, we gotta think for a second. 5 raised to some power is 1. Well, what number do I raise it to this power I always get 1 out of? Hopefully you figured out that that's 5 to the 0. So x in this case has to be 0. So log base 5 of 1 equals 0. Yay! Okay, so it seems those last three statements have some very nice generalizations that we can get from that. So we're going to make a list of some log properties and what they simplify down to.